Welcome to our channel. If you are new here, please join us by subscribing. Today we will focus on cloud computing. Welcome again. Cloud computing is one of the fastest growing technological trends in today's world. An ever-increasing number of businesses are turning to cloud platforms to help resolve their greatest technical challenges, some of which include remote work and cyber threats. One of the biggest attractions of cloud computing is how it transforms IT infrastructure into a utility easily accessible over the internet. Thanks to cloud computing, businesses with financial constraints are saved valuable resources they would have expended on installing and running on-premise devices. In this video, you will learn everything you need to know about cloud computing, including the leading cloud computing providers and emerging cloud technologies. Let's get started. Cloud computing is the on-demand availability of computer system resources, especially data storage, cloud storage, and computing power, without direct active management by the user. Large clouds often have functions distributed over multiple locations, each of which is a data center. Cloud computing relies on sharing of resources to achieve coherence and typically uses a pay-as-you-go model, which can help in reducing capital expenses but may also lead to unexpected operating expenses for users. The National Institute of Standards and Technology's definition of cloud computing identifies 5 essential characteristics. On-demand self-service. A consumer can unilaterally provision computing capabilities, such as server time and network storage, as needed automatically without requiring human interaction with each service provider. Broad network access. Capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms, example mobile phones, tablets, laptops, and workstations. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. Rapid elasticity. Capabilities can be elastically provisioned and released, in some cases automatically, to scale rapidly outward and inward commensurate with demand. To the consumer, the capabilities available for provisioning often appear unlimited and can be appropriated in any quantity at any time. Measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service, example storage, processing, bandwidth, and active user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Advocates of public and hybrid clouds claim that cloud computing allows companies to avoid or minimize upfront IT infrastructure costs. Proponents also claim that cloud computing allows enterprises to get their applications up and running faster, with improved manageability and less maintenance, and that it enables IT teams to more rapidly adjust resources to meet fluctuating and unpredictable demand, providing burst computing capability, high computing power at certain periods of peak demand. Additional value propositions of cloud computing include cost reductions. A public cloud delivery model converts capital expenditures, example buying servers, to operational expenditure. This purportedly lowers barriers to entry, as infrastructure is typically provided by a third party and need not be purchased for one-time or infrequent intensive computing tasks. Pricing on a utility computing basis is fine-grained, with usage-based billing options. As well, less in-house IT skills are required for implementation of projects that use cloud computing. The eFiscal Project's state-of-the-art repository contains several articles looking into cost aspects in more detail, most of them concluding that cost savings depend on the type of activities supported and the type of infrastructure available in-house. Device independence. Device and location independence enable users to access systems using a web browser regardless of their location or what device they use, example PC, mobile phone. As infrastructure is off-site, typically provided by a third party, and accessed via the internet, users can connect to it from anywhere. Maintenance. Maintenance of cloud environment is easier because the data is hosted on an outside server maintained by a provider without the need to invest in data center hardware. IT maintenance of cloud computing is managed and updated by the cloud provider's IT maintenance team, which reduces cloud computing costs compared with on-premises data centers. Multi-tenancy. Multi-tenancy enables sharing of resources and costs across a large pool of users, thus allowing for centralization of infrastructure in locations with lower costs, such as real estate, electricity, etc. Peak load capacity increases. Users need not engineer and pay for the resources and equipment to meet their highest possible load levels. Utilization and efficiency improvements for systems that are often only 10 to 20% utilized. Performance. Performance is monitored by IT experts from the service provider, and consistent and loosely coupled architectures are constructed using web services as the system interface. Productivity. Productivity may be increased when multiple users can work on the same data simultaneously, rather than waiting for it to be saved and emailed. Time may be saved as information does not need to be re-entered when fields are matched, nor do users need to install application software upgrades to their computer. Availability. Availability improves with the use of multiple redundant sites, which makes well-designed cloud computing suitable for business continuity and disaster recovery. Scalability and elasticity. Scalability and elasticity via dynamic, on-demand, provisioning of resources on a fine-grained, self-service basis in near real-time. Note, the VM startup time varies by VM type, location, OS, and cloud providers, without users having to engineer for peak loads. This gives the ability to scale up when the usage need increases or down if resources are not being used. The time-efficient benefit of cloud scalability also means faster time to market, more business flexibility, and adaptability, as adding new resources does not take as much time as it used to. Emerging approaches for managing elasticity include the use of machine learning techniques to propose efficient elasticity models. Security. Security can improve due to centralization of data, increased security-focused resources, etc., but concerns can persist about loss of control over certain sensitive data, and the lack of security for stored kernels. Security is often as good as or better than other traditional systems, in part because service providers are able to devote resources to solving security issues that many customers cannot afford to tackle or which they lack the technical skills to address. However, the complexity of security is greatly increased when data is distributed over a wider area or over a greater number of devices, as well as in multi-tenant systems shared by unrelated users. In addition, user access to security audit logs may be difficult or impossible. Private cloud installations are in part motivated by users' desire to retain control over the infrastructure and avoid losing control of information security. Cloud computing is the accessing and storing of data through the Internet. This is the delivery of hosted services like data storage, database, application, server, and networking at a remote center operated by cloud service providers. Another definition of cloud computing is that it is the use of off-site systems to store, process, and manage information that can be accessed over the Internet. Data stored on the cloud can be accessed through a secure network connection. Cloud computing makes use of multiple cloud servers to operate, thereby delivering fast and reliable services to many people. The use of the cloud has increased over the years because of guaranteed security, affordability, improved speed, round-the-clock availability, and scalable services. Cloud computing services are useful to virtually everyone, including the banking sector, educational sector, healthcare, government, businesses, communication, and personal use. 3 important components make cloud computing function. 1. Front end. The front end is the visible part of the computer. It is an important part that interacts with the end user, and it shows a connection to the cloud computing infrastructure. This part comprises the software application, the user interface, and the user's hardware. 2. Back end. The back end is located on a remote server and consists of hardware and storage. This contains the whole cloud infrastructure holding the following: Application, that is, the user interface. Storage formed by the server's hard drive. Virtualization used in creating cloud runtime. Service that executes every task on the cloud system. 3. Cloud-based delivery. These refer to the models through which cloud computing services are offered. This can be in the form of software as a service, SaaS, infrastructure as a service, IaaS, or platform as a service, PaaS. All three parts of cloud computing, front-end, back-end, and cloud-based delivery, are connected through an internet connection. The front end represents the user's device while the back end comprises many servers and storage systems that make up the cloud. The cloud is managed by a central server that attends to the requirements of consumers through the middleware. This middleware is software that allows communication between connected computers. Types of cloud computing services. 1. Infrastructure as a service, IaaS. Infrastructure as a service, IaaS, is a type of cloud computing service that allows a vendor to provide access to computing resources to many users. Important storage and network resources are made available based on demands. There is no extra cost for using this type of cloud computing service because it allows the freedom of selecting the resource of your choice. Making use of IaaS leads to the reduction of cost expenditure, improved business, and increased reliability. Examples of infrastructure as a service, IaaS, include Amazon Web Services, AWS, Microsoft Azure, Linode, Google Compute Engine, GCE. 2. Platform as a service, PaaS. Platform as a service, PaaS, is a computing service that provides an environment meant for the testing, managing, and developing of software applications. The third party provides the software and hardware tools to other users through the internet. Developers use PaaS to create applications and webs easily. Other services that PaaS provides include application testing and design, database integration, web service integration, and more. These services are all available on the infrastructure of the third party and accessible mostly through the web. Examples of platform as a service, PaaS, providers include Google App Engine, AWS Elastic Beanstalk. 3. Software as a service, SaaS. Software as a service, SaaS, is a software licensing model that allows cloud providers to host applications, making them available to users on the internet. There is no need to install such software, it is readily available online. This computing service gives access to data from any device with internet connection. Implementing software as a SaaS, allows you to easily modify software to suit your preferences due to its flexibility. SaaS providers use a highly secure public cloud to safekeeping their customers' data. Examples of software as a service, SaaS, providers include Salesforce, Dropbox, Google Workspace, Microsoft Office 365. 4. Function as a service, FaaS. Function as a service, FaaS, is used for the deployment of applications on the cloud. FaaS is also referred to as serverless computing. Application packages are built, managed, and run without developers making use of their personal infrastructure. Some examples of FaaS providers include Google Cloud Functions, IBM Cloud Functions, OpenFaaS. Types of cloud computing use cases, with examples. 1. Data analytics. The collection of large amounts of data requires a lot of resources which can be very expensive. With cloud computing, you only pay for the resources you need. This is cheaper, saves cost, and is easy to use. Software as a service model is used by cloud service providers for easy processing of data. Examples of SaaS providers include Microsoft Azure and Amazon AWS. 2. Desktop as a service, DaaS, or Virtual Desktops Infrastructure, VDI. Virtual Desktop Infrastructure, VDI, allows the use of virtual machines as cloud resources. They are hosted on the cloud and work to control, access, secure data, and information uploaded in the cloud. Desktops are logged remotely and workers have access to files from their personal devices, anytime and from anywhere. Examples of virtual desktop infrastructure, VDI, include Microsoft, VMware, and Parallels. DAS is similar to VDI but it is managed by the service providers. They improve security and are cost-effective. Examples of desktop as a service providers include Citrix, Desktone, a VMware company, and Amazon. 3. Email. Cloud-based emails are operated by third-party providers. They are usually separated from personal emails because they carry information about an organization or business. Cloud-based emails allow you to adjust your needs like storage capacity whenever you want and utmost security is guaranteed. Examples of cloud-based email service providers are Outlook, Gmail, ProtonMail, Yahoo Mail, and more. 4. Data backup. Data is backed up in the cloud by copying and storing files and applications on a particular server to a remote server. It can get lost through hacking, viruses, or accidentally. To avoid setbacks or total loss, it is advisable to back important files up to cloud storage. This helps to retrieve and keep your data intact. Some of the best data backup software include iDrive, Backblaze, and Acronis TrueImage. 5. Communication and online networking. Social media is used for calling, texting, and sharing information. Communication tools such as applications like Facebook, Instagram, WhatsApp, emails are developed on the cloud. This is where posts, messages, or media sent and received are stored. Through the internet, all these files are accessible. These applications are all hosted through the cloud. 6. Data storage and recovery. A very important use of the cloud is for storing files. The cloud provides access to files uploaded, allows editing and securing of data. You get to purchase as much storage space as you need at affordable prices. Also, if any data gets lost, as long as they have been uploaded on the cloud, such files can be easily recovered. It is cheaper and time-saving than using data recovery software. Examples of these cloud storage services include OneDrive, Dropbox, Google Drive. Cloud computing characteristics. There are several distinctive characteristics of cloud computing you should take note of. 1. On-demand self-service. Cloud computing gives the consumer a say in deciding the purchase of resources needed. Service consumers are allowed access to services without asking for permission or having to go through manual processes. These service consumers can monitor the server, storage, and computing capabilities. 2. Security. To prevent and guide against any form of data loss, there is a stored duplicate that can be restored in such cases. Data is kept safe in case of file corruption or deletion or cyber attacks. Examples of data security on the cloud are firewalls, data encryption, and more. 3. Broad network access. Cloud computing has large network access. Data can be accessed and uploaded on the cloud by users from any location in the world through the use of internet-connected devices like desktops, laptops, mobile phones, tablets, and more. 4. Resource pooling. Service providers pool computing resources like bandwidth, storage, processing to satisfy a lot of consumers through the use of multi-tenant models. Several users share these resources depending on their requirements. 5. Measured services. Cloud computing systems help to control the use of resources like network bandwidth, storage space to make sure there is a constant supply. This is to meet the demands of consumers. 6. Automation. Automation is the ability to handle automatic maintenance, installation, and configuration. This is beneficial in cloud computing because it helps to keep track and monitor activities without wasting time. Automation helps reduce the use of manual labor. Examples of automation tools include Microsoft Azure Automation, CloudFormation, and more. 7. Maintenance. Cloud computing is very easy to maintain. Resources undergo updates from time to time. This helps to optimize their capabilities and improve their functioning by making them faster than the old versions. Advantages of cloud computing. Cloud computing has a lot of advantages for business and personal use. The advantages of cloud computing are becoming very attractive for businesses as more and more businesses devote more resources to cloud computing models. 1. Efficient collaboration. Progressive teamwork is achieved through collaboration. Workers get to achieve goals and operate at the same time. Using the cloud helps for easy monitoring to avoid mistakes. This also encourages transparency. 2. Automated updates. Another benefit of using the cloud is the access to automatic updates. Your system, servers, software, and processing power will be upgraded to newer and better versions automatically. 3. Flexibility and scalability. Users of cloud computing can access their data from any location. They can also make quick changes in their demand for resources without adding extra costs or wasting time. 4. Affordable costs. Cloud computing is considered cost-efficient because all software and hardware needed are provided. Also, it is cheap to maintain because maintenance is covered by the service providers. There will be no delays, no need to pay for experts, and energy costs are reduced. 5. Mobility. Files stored on the cloud can be accessed anytime and anywhere as long as there is an internet connection. In cases where workers are not available at the company, they can be kept up to date with the happenings and developments in the company. 6. Security. Mostly, people use cloud computing because of security. Storing data on the cloud helps to keep your files safe from cyber attacks, virus attacks, and data loss. The use of data encryption and security measures such as two-factor authentication is implemented by cloud service providers to protect cloud data and information. Cloud computing challenges. Despite the numerous advantages of cloud computing, it is not without its flaws. Although cloud computing service providers are improving their cloud services, there are still some challenges confronting cloud computing. 1. Privacy and security. Although the use of encryption has been introduced to keep files on the cloud safe, there is no guarantee of complete privacy or security against hackers and other cyber attacks. Other ways to reduce breaches of privacy are data recovery software, the use of security applications, security hardware, and more. 2. Little or no resource. Lack of facilities or well-skilled workers can serve as a hindrance to the smooth running of the cloud. Organizations need to hire more experts in the field. Improved tools are to be made available alongside experts to operate them. 3. Reliability of cloud computing service providers. Cloud service providers must offer great services to their consumers. It is up to the service providers to render reliable services and access to computing resources. However, not all cloud computing service providers offer quality services. 4. Cost. The price of setting up and maintaining the cloud is on the high side. Most times, organizations spend too much on investing in the cloud. Bandwidth cost is expensive, especially for organizations with data-intensive applications. Enough bandwidth is required to deliver complex data on the cloud, hence, leading to high expenses. 5. Data migration problems. If there is a need for any consumer to migrate to other service providers, users may encounter difficulties due to restrictions placed by some cloud service providers. Not all cloud service providers make it easy for users to migrate from their platform to another. 6. Management of multi-cloud. The use of multi-cloud infrastructure has increased over the years in many companies. This is due to cost management and efficient output. Managing multi-cloud infrastructure is more challenging than operating a single cloud. Cloud computing deployment models. Cloud computing deployment models describe the environments meant for the installation of cloud services or applications for the use of consumers. There are 4 types of deployment models. 1. Private cloud. A private cloud is a type of cloud computing deployment model that provides an environment for just one business or organization, on a private network. This offers an improved degree of control to the organization. The purpose of the private cloud is an easy response to requests for digital transformation made by end users. There is security and limitation of access to certain data. Private cloud provides privacy, flexibility, and implementation of privacy policies. The cost of setting up a private cloud is expensive but saves resources. This is a type of investment because it allows savings due to the reduction of the cost of getting new hardware. Another benefit is time saving, allowing strategic technology decisions to be made. This also fastens the traditional ticketing process by a lot of IT organizations. 2. Public cloud. A public cloud is a type of model that allows accessibility to a wide range of users. This is available over the internet and is provided by third-party service providers. Unlike the private cloud, it is cheaper to set up, manage and make use of. In a company where the public cloud is used, various workers are allowed to make use of the application from any location and on any device. Additional security measures like intrusion detection and prevention systems, IDPS, can be used alongside to make the cloud as secure as private ones. One of the differences between private cloud and public cloud is that the former gives you more security. 3. Hybrid cloud. The definition of hybrid cloud, it is the mix of private cloud and public cloud. A hybrid cloud is a computation model that has an environment in which on-premises private clouds and third-party public clouds are operated. These clouds are bound together by proprietary technology that allows portable data and applications. Some of the best hybrid cloud computing solutions include Microsoft Azure, Alibaba Cloud, Amazon Web Services, Google Cloud Platform, and IBM Cloud Solutions. 4. Community cloud. The community cloud is a cloud computing model that is shared by several organizations with the same goals, or belonging to the same community. Its cloud data center is built to be shared by members of that community. Community cloud is considered more affordable than the private cloud and a bit more secure than the public cloud. Leading cloud computing service providers. Best cloud computing service provider with free features and cheap plans. Google Cloud is one of the best cloud computing service providers trusted by top companies such as Unilever, Twitter, Nintendo, PayPal, Shopify, Spotify, Toyota, and other users across 200+ countries. Main features. Databases. Manage your data services securely and efficiently on the Google Cloud Platform. You can easily migrate enterprise data securely and reliably on the platform and run critical workflows like Oracle, VMware, Windows, and SAP natively. Smart Analytics. Google Cloud helps organizations build their data cloud and turn complex analytics into actionable insights. This cloud computing service provider provides real-time business insights for faster and more accurate decision-making and eliminates constraints of cost, scale, and performance. Security. Protect your files in the cloud with Google's advanced security solutions. Google Cloud helps you to detect and tackle cybersecurity threats, protecting your information from damage, loss, or theft. Business Application Platform. Google Cloud manages most of your cloud services, making it easy for users to concentrate on other priority tasks. You can create applications easily and automate processes securely with no knowledge of coding thanks to its easy-to-use API functions. The API detects speech and translates languages easily. Productivity and collaboration. Connect with Google Workspace, which gives you access to popular cloud-based Google apps such as Drive, Gmail, Calendar, Docs, and Google Meet from any device. Benefits. 20+ free products such as free cost management tools and AI-powered recommendations. Free trial. Excellent user interface. An extensive set of APIs and developer tools. High security. Leading cloud computing service provider that offers enterprise-grade cloud computing solutions. Launched in 2006 by Amazon, Amazon Web Services, AWS, has come to be one of the largest cloud service providers on the Internet today. It is trusted by over 1 million users including top companies like Netflix and Airbnb. Main features. Cloud computing. This cloud service provider gives you solutions to inadequate computing resource problems, offering you virtualized computers and servers as well as a comprehensive management portal to track and control them. Front-end web and mobile development. you have features dedicated to your software development needs, specifically covering web and mobile applications. Storage: with AWS, you have a platform to store your enterprise-wide data and information. Storage goes as large as petabytes in size. Migration and transfer: your migration to and from other cloud service providers is made seamless through integrations and user-friendly policies. Benefits: scalable and flexible. Improved productivity. Unlimited server capacity. High security. Ease of use. Reliable encryption and security. Cloud security. Cloud security, also a cloud security application, CSA, is the act of protecting cloud-based data and applications from cyber threats and attacks. This refers to the steps taken to keep data and digital assets safe. There is constant monitoring and activation of alert systems. Individuals and organizations that save their data to the cloud for safety need cloud security for extra safety from security breaches, data loss, or data storage malfunction. Cloud security can be offered by in-house IT officials. Nowadays, third-party cloud security providers are mostly in charge of cloud security. While selecting which cloud service provider to use, precautions must be taken to prevent putting your data in the hands of potential hackers no matter who they are. 1. Firewalls. This is a network security system used for inspecting and filtering incoming and outgoing network traffic. This can be in the form of software or firmware. Firewalls are used to detect attacks and eventually defend your network against such attacks. 2. VPNs. Virtual private networks, VPNs, allow secure access to a company's data on the cloud by the employees through computer devices or websites. They are used to secure data from being accessed by just any device. Unlike traditional VPNs, cloud VPNs provide a global secure connection infused with the company's cloud. Some of the best VPN services include ExpressVPN, NordVPN, IPVanish, PureVPN, CyberGhost, Hotspot Shield, and ProtonVPN. 3. Data encryption. Encryption of data is a popular method for data security. This is the transformation of data to secret codes before storing it in the cloud. The codes can be decrypted by encryption keys. This is used for the limitation of access to data. 4. Two-factor authentication. Two-factor authentication is the use of additional security to protect data. It is the use of random codes in addition to usernames and passwords. Tools used in securing cloud are: Cloud Access Security Brokers, Cloud Security Posture Management, Cloud Workload Protection Platforms, Secure Access Service Edge, Zero Trust Network Access. History of cloud computing. There is no certain knowledge of who invented cloud computing. In the early 1960s, J.C. Ehrlichleiter, a computer scientist, on one of his many research attempts on other uses of the computer, envisioned the interconnecting and assessing of data from any location in the world. This idea was known as an intergalactic computer network. Since then, there has been a series of development and evolution on the idea of cloud computing. However, in 1990, Salesforce pioneered the storage of sales data on Salesforce computers. The model was quickly considered by various application developers. Around 2002, Amazon came up with Amazon Web Services, AWS. This was able to offer cloud-based services of storage and computation. Amazon Web Services was however restricted to individuals with credit cards. In 2006, another web service known as Elastic Compute Cloud, EC2, was released by Amazon. This allowed the rent of space on the cloud. Large organizations are not the only ones allowed to rent space on the cloud, but also small businesses without the need to own data servers. With Elastic Compute Cloud, E2C, cloud computing became accessible to everyone and not just large businesses. Challenges and limitations. One of the main challenges of cloud computing, in comparison to more traditional on-premises computing, is data security and privacy. Cloud users entrust their sensitive data to third-party providers, who may not have adequate measures to protect it from unauthorized access, breaches, or leaks. Cloud users also face compliance risks if they have to adhere to certain regulations or standards regarding data protection, such as GDPR or HIPAA. Another challenge of cloud computing is reduced visibility and control. Cloud users may not have full insight into how their cloud resources are managed, configured, or optimized by their providers. They may also have limited ability to customize or modify their cloud services according to their specific needs or preferences. In addition, cloud migration is a significant issue. Cloud migration is the process of moving data, applications, or workloads from one cloud environment to another or from on-premises to the cloud. Cloud migration can be complex, time-consuming, and costly, especially if there are incompatibility issues between different cloud platforms or architectures. Cloud migration can also cause downtime, performance degradation, or data loss if not planned and executed properly. Thank you for visiting and watching our videos.